Today we're talking about recursion. In terms of programming, recursion is basically a function calling itself, although there's a lot of flavors of recursion. And recursion is a pretty common concept, like a guy named Douglas Hofstadter wrote a book largely about recursion that was really funny. It was called Gödel, Escher, and Bach, the Eternal Golden Braid, I think. And he pointed out how Bach used recursion in his music, and Escher used his recursion in his art, and I think Gödel used recursion in mathematics, if I remember right. But in terms of programming, recursion requires absolutely one thing, which is a terminating condition. Because if you don't have a terminating condition, recursion will go on forever. It has sort of an infinity concept built into it. Like if you hold two mirrors opposite each other and you see them reflecting off each other, and you stand in the center and you see a million copies of yourself. That's another example of recursion, sort of self-reference. This is a picture of recursion I got in Wikipedia, which is basically a screen capture that's of a screen capture that's of a screen capture going back into infinity. You know, the same screen capture, of course. I wrote two console application recursion programs. And if we look at the first one, you see basically it's a function called factorial. I actually got this from Wikipedia too. I had to modify it a little bit because it was in C with unsigned rather than unsigned int rather than uint. But basically when we go into our main, the public static void main, which is the starting point, and we initially call factorial, we pass it a parameter, and then when we get into factorial, it takes that parameter and says, is it less than or equal to 1? And if it is, return 1. And this part here is actually the terminating condition, which prevents it from running forever. And then if it's not less than or equal to 1, we multiply the number times a factorial of the number minus 1. So this factorial is calling itself. It's calling the routine. So it's going to initially come in here and call factorial with a factorial of 8, and it's going to say 8 times, and then factorial of n minus 1 is 7. And so you have a concept in recursion that I've always found useful to describe as going out and then coming back. And sometimes with different flavors of recursions, you're actually going in different directions and coming back. But basically, while you're going out, you're really just putting things on the stack. You're saying n times 7, and then the next version you're saying 7 times 6, and so on, going out all the way. And then when you come back is when the real work gets done, because everything's resolved down to real numbers, and you start actually getting what a factorial is, which is a number times all the numbers before itself. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if we compile and run this program, might as well just copy this. Use enter to copy that, and then type CSC for the C# compiler, and press right mouse button to get that from the clipboard, and hit enter. We've got a compiled version. And then if we do right mouse click and get rid of the CS, we'll see it says the factorial of 8 is 40,320. If we'd passed to 4, we would have gotten 4 times 3 times 2 times 1, which would be 4 times 3, which is 12, times 2, which is 24, and times 1, which is 24. So we would have got the factorial of 4 is 24. To show what's actually happening in this program, why don't we back up using the up arrow key to go back commands. And as you see, I have a commented out console right here. And basically every time this is called, this prints out the number that it gets as a parameter. So if we save this and then use the down arrow to get the previous compile command and the down arrow to get the previous run command, you see the first time it's called it has an 8, the next time it has a 7, and so on. So we're actually calling it 8 times even though we only see one call. This is an example of what's called pre-order recursion when we put that print out there. Pre-order recursion says basically do something before you recurse. There's also post-order recursion, which says do something after you recurse. And then there's in-order recursion, which involves recursing twice. You recurse, then do something, then recurse by a different criterion. So if we look at the second program I wrote, here I have a recursing function called ordering. I couldn't use the previous one to show the two types of recursion because I couldn't do post order because it has a return built into the recursive call. But in this one, the terminating event is that if n is actually this says if n is less than 1, stop recursing. But the way it's phrased is if n is greater than or equal to 1, then recurse. So it's the converse way of recursing, but it's essentially saying the same thing. As long as n is greater than or equal to 1, we're going to call ourselves, and we call ourselves with n minus 1. So essentially doing the same thing as the previous one, but phrasing it differently. And in this we have a console write line at the top, which says what the number is we're passed as we're going out, so to speak. And then we keep going out and keep calling ourselves, and this keeps writing. But then once we're all the way out and we no longer are calling ourselves, it's only then that this will start to act as we're coming back, so to speak. And this will start to print out the post-order recursion as the stack unwinds and we're coming back from the recursion. So if we compile and run this, you notice we have the same thing with pattern we had before, this time going from 8 down to 0. Because we're printing out before we actually stop recursing when we get to 0. And then we start printing out as we're going back. So the numbers are going down as we go out, but they're going up as we go back because the incarnation of the function, as it's sometimes called, you know, the current version of the called function is now getting bigger and bigger as it unwinds off the stack. So we go from 8 to 0, and then from 0 to 8. And in order recursion, we have a situation where we're either creating something like this binary tree, where you have a left branch and a right branch, or we're printing out this binary tree in alphabetical order, like if you want to print A, B, then C, D, E, and so on. And basically at the top of the in-order recursive function would have a call that goes on the left branch. So it go on the left branch and it says, is this branch null? And it says no, so we recurse on the left branch again and we go, is this branch null? And we say no, and then we hit the A and we say, is the left branch null? And it is. So we print out the A. And then we'd start to go backwards. So we'd have the situation where we're printing the thing at the bottom. and we're doing the post order recursion. So this one, where all we did was go back, now we're printing as we go back. So we print A, then we print B, and then it hit the bottom order recursion after it did the print. The print's in the middle, remember, and it'd go on the right branch, and it'd go on, it'd say, is the right branch null, and it'd say no, so it'd go to the D node, and then the D node would look at the left branch and say, is the left branch null, and it'd go to the C node, and then it'd say, is the left branch null, and it'd say yes, so it'd print out the C, and then it'd fall through and say, is the right branch null, and it is, so it'd fall back again, and then we'd print out the D, and then this node would check as the right branch null, and it'd say no, so it'd print out the E, and so on. And then finally we go all the way back up and we print out the F, and then we'd fall through and check our bottom recursion and say, is the right branch null, and it'd say no, and it'd go to the G, and so on. So you can see with a structure like this binary tree, you can both create the binary tree and then print out the binary tree with two functions that are about 3 statements long. Literally 2 3-statement long functions, and you could print out something that needed to be sorted through thousands of records with those 6 statements. Well, I hope you enjoyed this tutorial and learned a lot, and don't forget to subscribe.